study about another polysaccharide, glycogen. It is a homopolysaccharide. Since it is a homopolysaccharide, it is made up of only one type of monosaccharide, that is alpha D glucose residues. Okay, and it is the major energy storage form in animals, fungi, and bacteria. Actually, this glycogen is an analogue of starch in plants, but the major difference is glycogen is extensively branched. So, since it is an analogue of starch, this glycogen also contains linear chain structure like amylose and branched structures like amylopectin. Okay. Normally, two glucose residues are linked together through alpha 1,4 residues, but in the branching point, specifically alpha 1,6 linkage is present. Since glycogen is extensively branched, branching occurs after every 4 to 6 residues. Here you can see the cross section of glycogen granule, a two-dimensional view. Okay, it is highly branched complex structure. This structure may contain up to 30,000 glucose units, but the central part is occupied by a protein known as glycogen. Partly it is having an enzymatic activity, that means it initiates the polymerization of glucose residues. Okay, that means initially it start polymerizing glucose residues and synthesizes a small primer contain up to 7 glucose residues. Thereafter, this synthesizing role is taken over by another enzyme known as glycogen synthase. This gives a brief idea about how this glycogen synthesis is initiated by glycogenin protein. Okay, in the initial stages or in the first step, this glycogenin autocatalytically transfer glucose units, especially UDP glucose units, to its tyrosine residues. Okay, this catalytic process continues up to 7 glucose units. Thereafter, two enzymes, mainly glycogen synthase enzyme and a branching enzyme, they take over this role of glycogenin and they start synthesizing glycogen molecule. This gives an idea about the different levels of organization of glycogen. In level 1, several individual glucose residues were connected together through alpha 1,4 glycosidic linkage and several branches were formed with the help of alpha 1,6 glycosidic linkage. So it is the basic initial polymerization stage. In level 2, as a result of continuous polymerization of alpha D glucose residues, it leads to the formation of a highly branched complex structure. Okay, there you can see here. Later, this highly branched complex structure globularized to form small granular structure known as beta particles. In case of liver glycogen, it has a third level, a supramolecular clustering level, where beta particles which form larger clusters of alpha particles.